Hello, and welcome to a video on functions brought to you by the Answer series. With increasing and decreasing functions, we always read the graph as x increases. In other words, we go from left to right. So if I go along this graph from left to right, I'm going down until I get to the turning point, and then I go up. So initially the graph is decreasing. It's stationary at the bottom, and then it is increasing. So when I ask you for what values of x is f of x increasing as x increases, it means where is it going up? And it's going up there. What are my values of x? Well, x is greater than 4, which is the x value at the turning point. If I ask you for where is it decreasing, it's where is the graph going down. So where is the graph going down? There. So what are my values of x? It's when x is less than 4. A second example, again with a parabola, and I ask you for what values of x is f of x increasing and where is it decreasing. Remember, we always go as x increases. If I go along my parabola, I go up till I get a stationary point at the turning point, and then I go down. So where is my graph increasing? It's when x is less than 1. Where is it decreasing? When x is greater than 1. The second thing we're going to look at is the average gradient. Now, if you've been given a curve and they ask you for the average gradient between 2 points, what they mean is they want you to take the 2 points, imagine there's a straight line drawn between them. So it doesn't matter what the original graph is, take the 2 points, imagine there's a straight line drawn between them, and get the gradient of that straight line. So a reminder that the gradient of a straight line is y1 minus y2 over x1 minus x2. So what you do, I've asked you to determine the average gradient between x equals 5 and x equals 7. So you take x equals 5 and you get the corresponding y value by substituting it into the original equation. You then take x equal to 7, and again, you substitute it in. So you get the coordinate when x is 5 and you get the coordinate when x is 7. And you imagine if you have a straight line joining those 2 points, you need to determine the gradient. So pause the video, get the coordinates, get the gradient, and then we'll do it together. Okay, so when x is 5, I get a y value of 1. When x is 7, I get a y value of minus 1. I use the equation of the gradient, substitute the 2 coordinates in, and I get a gradient of minus 1. The next thing we're going to look at is transformations. And I'm going to take parabolas and I'm going to move them, and we're going to see what happens to the equations. So I've given you f of x is equal to minus x minus 1 squared plus 4. This graph has a turning point of 1, 4. And what we're going to do is we're going to determine the equation of the new graph obtained if f is firstly translated 2 units left, 1 unit up, reflected in the x-axis, and rotated 180 degrees about the origin. Now before I do them, I want you to pause the video and I want you to try these yourself. A hint to you is take the turning point, see how does the turning point change underneath these transformations, and see if you can get the equations. So pause the video and then we'll do it together. In the first one, you have to translate 2 units left, 1 unit up. So we take the turning point, we go 2 units left, 1 unit up, and the turning point ends up there. So the coordinate of the turning point, if I go from an x value of 1 and I go 2 left, I get minus 1. The y value is 4, I go 1 up, so I get 5. So what is the new equation of my graph? It's y equals, my x value is minus 1, so it comes from the bracket x plus 1, all squared. My y value is 5, so there's a plus 5 on the end. When I translate this graph, it looks something like that. So the shape of my graph has not changed at all. My a value in the original equation was minus 1, so my a value in the new equation stays minus 1. In the second example, I asked you to determine the equation of the graph if I reflect it in the x-axis. There's my x-axis. If I'm going to reflect it in the x-axis, it means I use the x-axis as a mirror, and I take my graph and I get the mirror image. So my turning point is 1, 4. If I reflect it in the x-axis, I get my point down there. So I've reflected that turning point in the x-axis. The coordinates of this point is 1, minus 4. So the equation of my graph is y equals x minus 1 squared minus 4. Now what has happened to my graph when I reflect it is the whole graph has turned upside down. My a value in the original graph is minus 1. So what is my a value in the reflected graph? It's plus 1. In other words, my equation is y equals x minus 1 squared minus 4. In the final example, I asked you to determine the equation of the graph if it is rotated 180 degrees about the origin. Now imagine you take the origin and you take a piece of string to that turning point. You're going to rotate it 180 degrees. Now whether you rotate it clockwise or anti-clockwise doesn't matter. You get to the same point. So if you rotate it 180 degrees, you get to that point, which is minus 1, minus 4. So the equation of my graph is y equals x plus 1 all squared minus 4. Now, what has happened to the graph when I rotate it? Well, when I rotate, it looks like that. My original a value was minus 1. So what is my new a value? It's plus 1. So the equation of the rotated graph is y equals x plus 1 squared minus 4.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.